Hello, it's Professor Gibson, and this is a video on expected value. Okay, so there's formal letter statements and things about it, but really what an expected value is if you performed a particular thing a bunch of times, there's more than one thing that could come out, like you could win or lose, or maybe there's, three or four possible outcomes here, maybe several. And the expected value would be if you did it a bunch of times over and over and over, what would the average result, what would you expect the average result to be? All right, so that's what the expected value is. Kind of as a word formula we have here, right here. The expected value is the value of the first outcome times the probability of that outcome, plus the value of the second outcome times the probability of that outcome. And then you just repeat this for however many possible outcomes we have. All right, if there are only two, you just have outcome 1 and 2. If there were 4, you'd have 4. All right, let's work a couple of examples here. Example 1, the prize in a raffle is a flat screen TV valued at $350. 1,000 tickets are sold for $2 each. What's the expected value if you buy one ticket? All right, well, so how many outcomes are there? Really, there's only two. You can either win or you can lose, right? If you win, what's the outcome? Well, I'm going to type in equals here. You win the $350, but you've also had to buy one ticket, right? So you really win 350 minus 2, you win $348. If you lose, the only thing that happens is you lose that $2 for your ticket, so minus 2, right? So if a win outcome, you gain 348, a lose outcome, you lose 2. The next thing we need is the probability for each outcome. Well, there's 1,000 tickets and there's only one winner, so that's equals 1 divided by 1,000. All right, and then now for lose, there's still 1,000 tickets, but there's 999 losers, so that's 999 divided by 1,000. Okay, so there's my probability. Now, to compute the expected value, I got to multiply each outcome times its probability. So type in equals, select the outcome, times the probability. Okay, and then again, in the next row, in the lose outcome row, equals, type the outcome minus 2 times the probability. Okay, and then the overall expected value, we're just going to add those together. $1.65. So cost of a ticket is $2. On average, you kind of lose $1.65 of that. Okay? Okay, if you do it a bunch of times, on average, you expect to lose $1.65. Let's do another one. On a roulette wheel, there are 38 slots, 18 of which are colored red. If you bet $5 on red and win, you get $10 back. If red doesn't come up, you lose your $5. Okay? All right. So again, we're going to win-lose. You have to be careful about the wording. Because this one says you get $10 back, makes it sound like the $5 goes in, right? So if you win, you get $10 minus the 5 is the way it reads. All right. Sometimes in a game like this, like if you actually go to most roulette wheels, you keep the $5 and the 10, so you'd actually gain 10. But I'm just going with what this actually says. If you lose, then that's -5, right? You lost your $5. What are your probabilities? Well, the probability of winning, right? There's equals again, there's 18 red spots divided by 38 total. And the probability of losing then, if there's 38 red, then there's going to be 20 that are not red. Okay? All right. So now for each row, we do this again. So equals, click on the outcome, times the probability of that outcome. All right. And then for the lose, equals, what happens if you lose, times the probability of losing. And you know what? Let me make those a little bigger so it's easier to see. And then we have to add those two up for this last column up for the overall expected value. So this one is minus 2.63. So basically, on average, you play this for a $5 bet, you expect to lose 26 cents. Okay, that is expected value with 2 examples. I hope you found that helpful.